at this point, we now have our z-score formula along with the understanding of how to use our z-tables, and those two things together allow us to find the probabilities related to any normal distribution. So let's look at a problem. We've got a ketchup factory where the amounts that go into the bottles are supposed to be normally distributed. So first of all, you're going to want to be on the lookout for that term, normally distributed. That tells me I'm going to be using z-scores. I'm going to be using my z-tables. We have a mean of 36 ounces. Let's pause and make a note here. Our mean is equal to 36 and a standard deviation of 0.11 ounce. So our standard deviation is 0.11. We need to have these two things before we can do anything else with this particular distribution. So moving on, we're going to look at a few different examples related to this distribution. We want to find the probability that a randomly selected bottle has more than 36.15 ounces of ketchup. So in general, I think it is always a good problem just to sketch out what this is going to look like on your normal distribution. It does not have to be a particularly detailed graph, but I'm going to draw the graph anyway. So here's my normal distribution. Perhaps it looks something like this. And I know the mean is 36. That number lives right in the middle right there. And I want to know what's the probability that it has more than 36.15. So that's my observation. First of all, 36.15, this number right here, that's going to live somewhere to the right. It's greater than my mean. So let's just say here's 36.15. It lives somewhere to the right of the mean. I don't necessarily care about how far it is. We're just going to put it somewhere to the right. So I'm talking about this data value right here. And if I say I want to know the probability that has more than this value, well, the values that are more than 36.15, those would live over here somewhere to the right. So this problem is really asking me to find the area to the right of 36.15. So in order to find this, I'm going to have to do a couple things first. I need to start by finding the z-score corresponding to this. If I'm going to use my z-tables, I have to find the z-score for this observation. So my z-score formula, just in case we've forgotten, is z equals x, which is my observation, minus my mean divided by my standard deviation. So let's go ahead and plug these in. My observation was 36.15 minus my mean is 36 divided by my standard deviation of 0.11. So if I grab my calculator real quick, 36.15 minus 36 and divide by 0.11, my z-score ends up looking like 1.3636 repeating. For z-scores, generally 2 decimal places is enough. That's all our z-table tells us, so that's all I'm ever really going to use. So my z-score is 1.36. So this has a z-score of 1.36. So another way that I could phrase this question is I could say I want to find the area to the right of 1.36. And at this point, we now need to hop back to our z-tables and use that to help me find this area. So let's go ahead and hop back over here. We want a positive z-score, so we're going to scroll down to our positive z-scores, and let me erase stuff from our last video. So we said our z-score is 1.36. So the first number in decimal, our z equals 1.3. We should be looking at this row right here. And 6, here's that second decimal, so I would be looking at this row right here and this column right here. So my area is 0.9131. Now we have to remember, though, that this normal probability table only tells us area to the left. So this is our left area, which is not quite what we want, but we can fix it. So from my z-table, I know that this area to the left is 0.9131. That's not quite what I want. I wanted area to the right. I know that I can find that by subtracting the area to the left from 1. So I want 1 minus the area to the left, 0.9131, and that will give me 9131 gives me 0.0869. There is my probability. So we just have a couple of these extra added steps where we're going to have to find the z-score first, and then once we have that, we can use what we know about our z-tables to find the area corresponding to that. Let's take a look at a couple more here. Part B says find the percentage of ketchup bottles that are below 35.77 ounces. Again, I'm going to take a second just to go ahead and draw out what this looks like on our normal curve. So here's my normal curve. The mean we said was 36, and 35.77, that is less than the mean, so it's going to live somewhere over here on the left. So let's say here's 35.77, and I would like to know the percentage that are below this value. In other words, less than that value. So I must be talking about the area to the left over here. So I know the area that I want to talk about. I just need to find the z-score corresponding to this number. So z equals my observation, which is the data value that I have, 35.77, minus my mean is 36, and then we want to divide that by our standard deviation, which is 0.11. So if you want to grab your calculator for a second, 35.77 minus 36 divided by 0.11 gives me, I ended up with z equals negative 2.09 repeating, so we'll just say negative 2.09. One thing that I'll mention, if you are going to try and do the z-score formula all in one step in your calculator, you are going to have to put that numerator in parentheses, so just be extra careful. I will usually just go ahead and calculate out the numerator and then divide the denominator in a separate step. But here's our z-score, negative 2.09. At this point, we just want to find the area to the left of this value. So the area to the left of negative 2.09, we need our z-table. So let's scroll back up and let's erase so that we can start with a fresh, clean slate. We said this time around our z-score was negative 2.09. So here is negative 2.0. We must be talking about this particular row right here. So let's highlight that row. And then 9, that second decimal right here, we're looking all the way at this far left-hand column over here. Here's 0.9. So that means that the area to the left of this number, 0.0183. And that's all I really needed to do. I'm going to go ahead and hop back over and just make sure that I make that as my answer. This area is 0.0183. 0.183. The only thing I have to do real quick is convert this to a percentage. As it's written right now, that table will only give us probabilities. So that is just 1.83%. So just be careful as you're working on the homework that you read whether the problem's asking for a percentage or a probability, because it may ask for either one. Let's take a look at one last example here. Part C says, what percentage of bottles weigh between 35.82 and 36.3 ounces? So again, we have this area between two different numbers, just like we had in our last video. So again, let's take a moment just to go ahead and draw out what this looks like. My mean is right in the middle, is 36. We have the first number, 35.82, which is a little less than 36. So that will live somewhere over here on the left, 35.82. And then 36.3, that's a little bit greater than the mean. Perhaps that lives somewhere over here. And I want to find the percentage between these two values. In other words, the area between these two numbers on my normal curve. So in this case, because I have two separate observations, I am going to have to find two separate z-scores. So let's start by finding the z-score. We'll work left to right here. The z-score corresponding to 35.82. So first of all, z equals 35.82 minus my mean is 36 divided by our standard deviation. We said that was 0.11. So 35.82 minus 36 over 0.11 gives me negative 1.636 repeating, so that would be negative 1.64 rounded to 2 decimal places. So this corresponds to z equals negative 1.64. I'm going to do the same thing now for 36.3. Let's find that z-score. So z equals x, which is my observation, 36.3, minus my mean is 36, divided by my standard deviation, 0.11. So 36.3 minus 36 divided by 0.11 gives me z equals 2.727, would round to 2.73. So this z-score is a positive 2.73. So I've got my two z-scores. At this point, I now need to find the area to the left of each of these two and subtract them. This time around, I'm going to go in reverse order. I'm going to start with that positive z-score, and I'm going to find the area to the left of positive 2.73. So the area to the left of positive 2.73. Let's hop back to our z-tables. Positive z-score, we should be looking at the next page. So the positive 2.73. Let's erase this. We said positive 2.73. We'll start off with 2.7. We must be looking at this row right here. Here's 2.7. So let's highlight that row. And then the second decimal, the second decimal is a 3. We're looking at this column. So we must be looking at this column. The area to the left of that number is 0.9986. 68, excuse me. So let's hop back and just quick make a note of that. The area to the left of positive 2.73 is 0.9968, which we know is too big because it's going to count all of the area to the left, including this little area right here, which I don't want to think about. So I need to subtract that. So in order to accomplish that, I'm going to find the area to the left of negative 1.64. So hopping back to our z-table one last time, our z-score this time around was negative 1.64. Negative 1.64. Let me actually just double check. Now I'm second guessing myself. Yes, negative 1.64. So our z-score is negative 1.64. Let's start fresh here. Negative 1.6. We must be looking at this row. So here is negative 1.6. And then the second decimal is a 4. So we're looking at this column right here. So we're looking at this column. The area to the left of that number is 0.0505. So I know the area to the left of negative 1.64 is 0.0505. So to finish this problem up, if I want to know this area in this middle section right here, that highlighted yellow region, I'm just going to subtract these two areas. I'm going to take the larger area minus the smaller area. So 0.9968 minus the area that we want to take away that we don't want, 0.0505. This will leave me with only the area in the middle. So 9968 minus 0.0505 gives me 0.9463. That's the probability. Let's just double check and make sure we didn't want a percentage. Yes, this did want a percentage. So okay, we'll convert it really quickly. This would be 94.63%. So in all of these problems, I would highly recommend drawing a picture. I do think it's extremely helpful to visualizing that area, so that helps you to think about, okay, do I want area to the left, area to the right, area in the middle, perhaps area in the tails. That picture really